We've noticed you're manoeuvring very close to Gimbal Lock. I suggest you move back away. Over.
Yeah, I'm going around it, doing a CMC auto maneuver.
Roger, Columbia.
How about sending me a fourth gimbal for Christmas?
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts here in North Devon, Matthew and George Russell.
Oh yeah, baby, Collins and Garriott. Do you know what that is, George?
It's an actual quote from Apollo 11.
Yeah,
about Gimbal Lock and
Gimbal Lock. Yeah.
Euler rotation.
Euler rotation, I like it. Yes. Yeah, we're gonna have a little chat about that, aren't we? Because that's what you wanted to talk about.
Yeah.
Oh, by the way, it's George. George has joined me on the podcast 259. Hi, George.
Hi.
Did you have a nice week?
It's I have a decent week. Yeah.
You still been working on your short film?
I have. I mean, it's quite hard, making especially character animation. But
Okay. I just thought this week's been pretty busy, so I thought we'd do a sort of space news first this week because there's been lots going on. Before we go on to Gimbal Lock and Quaternions, which I know for some reason you phoned me up and said we got to do this, and I agree, it's quite fun. But a little bit of space news first. So, have you seen all the lovely pictures of the James Webb Telescope? Now it's arrived at the CSG in French Guiana.
I haven't seen those photos.
No, you can't play piano now. Yeah, so yes, James Webb has gone down the Panama Canal, not the Suez Canal, like I ridiculously said on a previous episode. It has gone down the Panama Canal and arrived on the MN Colibri at down the shallow Karoo River, and it's now at the CSG and it's been unpacked. And you guess what lucky little beep gets to see the photos first as it gets all unpacked and stuff?
Is it? I don't know. Who is it?
Julio. Julio's been posting all the pictures of James.
Really?
Yeah. So he gets to see those pickies.
Sure, like John Bennick isn't camping outside with like telescope and stuff.
Yeah, that's the sort of thing he'd do. So there's one more Ariane 5 launch before the big one. So Ariane should be this week, I think. There's an Ariane 5 launch with a couple of commercial satellites. And then that's it. If that goes really well, we'll see James Webb launch this year.
Where's that? That's just going to geostationary.
No.
Further.
Oh my gosh, George! Do you never?
Oh wait, no.
Do you never listen?
Lagrange.
Yes.
I knew that.
Yes. Oh my gosh! It was like you never listened to the podcast.
Lagrange point.
Unbelievable.
Which one though? L1.
L2.
Oh, nice.
Yeah, this one. I have my favourite. I think L2's my
favourite.
L2's
your favourite.
Yeah, L2's my favourite. I think it's L2 anyway. And you mentioned just now that that a couple of cosmonauts, or are they cosmonauts, landed back down this week. What were they doing on the ISS?
They were filming a film.
They were filming a film. It's going to be the very first feature film, or part of a feature film, ever shot in space.
Yeah, I mean that's...
Why the Russians? It almost feels like the Russians have done it just so they can be first at something again. It all seems a little bit rushed. So this was a Russian actress called Yulia Peresild and a film director called Klim Shipenko. They went up to film a movie. Guess what the movie's called?
Is it called... I don't know what it was. What is it called?
It's called The Challenge, and it's a kind of sort of semi-docudrama about how easy it is to train two people up to go up to space to film a film. It's a meta film. It's a meta film, yeah.
It's like the episode of Community.
Yeah,
with Arbed and. It's like that, but like actual and in space.
It's like actual, yes, but in space and obviously very expensive. Quite controversial this is, because some people in Russia have been saying that it might even be illegal to spend Russian money on non-scientific purposes on the ISS.
I suppose the experiment is: can you film film in space?
Yeah, well, weirdly, that's exactly what Dmitry Rogozin, the Mr. Trampoline Man.
Except I was being sarcastic.
Except you were being sarcastic, except he said, an experiment to see if Roscosmos can prepare 2 ordinary people to fly in 3 or 4 months.
That's slightly more, better.
Yeah, okay, it is slightly. So lots of criticism. In fact, one of the guys... this one guy got sacked. Sergey Krikalov, director of crewed programs at Roscosmos, he got sacked for speaking out and then reinstated a few days later when the cosmonauts all went a bit mental about, hang on a second, you can't get rid of this guy because he's an absolute legend.
Can't get rid of
Krikalov.
Sergey, yeah.
Yeah, Sergey Krikalov. You're joking, aren't you? You can't get rid of him. So they
bankrupt.
So they reinstated him. They've been filming on the ISS for this particular movie to see whether it was possible to train 2 ordinary folk to go up. And the spacecraft itself, the MS-18, I think it was, that had to be rejigged so that only one person could fly it. So there's only one commander on there, like a proper cosmonaut.
Right.
And the other 2 are obviously passengers. And the whole thing had to be upgraded so they could do it.
Well, it basically flies itself anyway.
Yeah, I know.
They've never actually used the manual docking ever, I don't think. Or have they?
Well, yeah, they have. The manual docking they've definitely used because during the Mir space station, that's when they were trying out all the sort of automatic docking procedures and stuff.
Right. Like the modern iteration of the Soyuz, surely.
Oh yeah, no, it docks automatically, but no, they still have to occasionally take control and dock it.
Yeah,
I believe even with Tim Peake's Soyuz, they had to sort of back out a bit and then manually dock it. The docking bit though, easy.
Yeah.
Now, but see, here's an interesting point. In your brain, you must have some kind of inertial measurement unit so that you can kind of work out your orientation. But we'll get onto that.
I suppose it's only relative, though. It's not like from your birth, your orientation from that
From
point.
your birth. Well, yeah, no, just like a normal IMU, I guess it needs calibrating every now and then. Yeah. Yeah, but it does because you feel sick after a car journey because it's kind of uncalibrated.
If you close your eyes and spin around,
yeah, exactly.
It's like
oh my God! Yeah, that makes me feel slightly sick just thinking about it. That's quite funny. I'm quite looking forward to watching that. And of course, that's the Roscosmos are ever expanding the Russian orbital segment of the ISS.
What happens if the footage actually accidentally got deleted? That would be pretty annoying. It's not the sort of thing you can reshoot.
Yeah, it'd be a very expensive thing to reshoot. That's a really good point. All the equipment went up on MS-17, sorry. They went up on MS-18 and then have landed back down on MS-18 on 17th of October, which I believe is today. So it's just happened. Exciting, huh?
Pretty crazy.
Yeah. MS-19 is set to land on the 28th of March, 2022.
Although it's not the first thing that's been shot in space. The moon landings, by direction of
Neil Armstrong,
by the director, that faked the moon landings. He was so specific that they had to shoot
actually shoot it on the moon.
On the moon, yeah. Because you can't
shoot it on location to fake it.
Yeah, exactly.
Well,
it has to be shot on location.
Classic example of fake it till you make it.
Exactly. Except you're making it till you fake it.
They faked the moon landing so accurately that they ended up actually making the moon landing.
But they still brought the set and the sound stage with them.
Yeah. Well, the only money you would save by faking it is
catering.
Is catering. Yeah, absolutely. So that's interesting. So a Russian film's been shot in space. We've also had a launch to the Chinese Changgong space station. There's been a launch to the Changgong as well.
I didn't know that still was I thought that was retired.
No. Changgong 1 and Changgong 2 have both been burnt up, but Changgong
Changgong. They haven't called it Changgong 3.
No, because it is the Changgong. Changgong 1 and Changgong 2 were sort of like the test space stations. Changgong has gone up.
Changgong is this is recently built then, or
Yeah. This was went up. It's been manned up until September. The first 3 crew, and the second 3 crew have gone up this week, and they consist of, and this is Shenzhou 13 went up, and that has taikonauts Zhai Jinggang, Wang Yaping, and Yi Hangfu. And Wang, I believe, may end up being setting a new record for a Chinese taikonaut of 180 days. 195 days in space, which is pretty impressive. And of course, she's the first woman to visit the Changgong space station as well.
How many people have visited?
Well, there was 3 on there until September. And they landed in September, and then this 3 have gone up. So 6 in total on Changgong.
And let's just hope for many more.
Oh yeah, absolutely. And what's crazy about the Russian segment that's going up soon to the ISS means that the Russian segment of the ISS can dock with the Changgong.
How close are they then?
Oh, they're not very close at all.
So they would never do that.
Well, in the film, what's it called? The one with Sandra Bullock, where they get hit by space debris. What's it called? Is it called Gravity?
Gravity, yeah.
Yeah, Gravity. In Gravity, she sort of floats over to the Changgong.
But it's very unrealistic because the Changgong is like...
Yeah, you just wouldn't be able to do it. It's in a completely different inclination. As you know, that orbital mechanics of going across inclinations is like insanely difficult.
Well, technically, you would only need a small amount of fuel if you're willing to wait like many years.
Yeah, I don't think she had many years to spare though. It was like it's not quite accurate. But hey, that's fine. So yes, there's another Changgong, Shenzhou 14 mission is the one after this. So another 3 were joining that. So the Changgong's going really well. Well done, Chinese. SpaceX have been having a go at the British rival OneWeb because SpaceX are basically saying that that OneWeb are trying to kind of get the regulator to get everyone to play ball with each other. And that's slowing down their Starlink superfast internet access for customers. But OneWeb have basically pointed out that they're the first people to have a proper international agreement to actually do this thing. So they had it first. So SpaceX are the kind of agents of change and getting in their way rather than the other way around.
Right.
It's interesting, isn't it? So, yes, so it's also starting to shape up the OneWeb SpaceX battle. And Bezos has been wading in with sort of saying, that the Starlink satellites aren't stable enough and they're not good enough. And Elon Musk getting a strop about that as well.
There's only room for one relay mesh in orbit.
Is that right? Do you think?
I don't know.
No, I don't know. I would have thought they're slightly different systems, aren't they? OneWeb and Starlink. Starlink is going to be sort of relying more on direct communication with a satellite, whereas OneWeb is being slightly smarter and communicates with ground sort of stations and relays it on. So there's slightly different technology. So it's interesting. But also OneWeb are obviously launched on European style Soyuz out of CSG normally. Although they have been out of Vostok as well. So they've been launching on Soyuz, but they've just signed an agreement to launch on the GSLV Mark III, which of course is India's nice big heavy lift vehicle.
Is it the first heavy lift vehicle?
No, it's not their first one, because you think the Mark III might suggest that there was a Mark II before.
The Mark II might not be, might be like the Changgong 2.
Yeah, it might be like the Changgong 1 and 2, although they were actual space stations. So, yeah. So, it's Ariane Space normally fly the OneWeb up, but the Indians are now looking like they might do as well. But yeah, SpaceX are also going to be launching Varda space satellite, which is another of these satellites that's there to try and launch manufacturing into space. So it's a kind of test thing. So they're going to fly a bunch of materials up into space, land it, and see how space affected those materials. So we're sort of slowly inching towards manufacturing in space as well.
Yeah, I mean, that's an important one. Asteroid mining and things like that.
Yeah, asteroid mining to get the raw materials, and then actual manufacturing in space. Manufacturing in space is goes all the way back to Soyuz 6, I think it was, where they tried to do a bit of welding.
I mean, they've done loads of like repairs and things.
Yeah, and obviously in the International Space Station, they've got a 3D printer. And they, make fiber optic cables up there and stuff like that.
Yeah, I mean, if your resources are from space, why bring those resources down back?
You'd be mental to. Yes, exactly.
Just to then bring them back up.
It is true. Whatever you make in space, you better mine it in space as well, or else it really kind of.
Also, whatever you mine in space, if you're planning on making it into a rocket, just make it in space.
Make it in space or on the moon, somewhere where there's a smaller gravity well.
Yeah, true.
Because sometimes it's quite nice to have like a firm base to build it on.
Sometimes, although sometimes the zero gravity is is good. It means you don't have to worry about it like breaking on its own weight.
Radiation, though, oh man, radiation is still a problem when you start reading about it. So that's all very interesting. George, go on then. Tell me a little bit. Well, I'm going to tell you about Gimbal Lock first. Before you tell me about the solution, which you were telling me about. So, Gimbal Lock, as we heard, they had a bit of a Gimbal Lock problem on Apollo, and one of the reasons why is they chose very early on to have a 3 gimbal system, which is normal. So, I suppose we should really start with the kind of 3 degrees of freedom that your spacecraft has.
Yeah. So for at least in the 60s and things, like planes and rockets as well, we're using Euler rotation, which is pitch, yaw, and roll.
So I'm going to explain pitch, yaw, and roll. So if you get your hand and stick it on a table flat, yaw as if you're wiping the table. So if you're moving your hand left to right, that's your yaw of your aircraft. If you imagine your fingers being the nose of the aircraft. So that's your yaw.
And your thumb and pinky being the wings.
Yeah, and so if you're sort of wiping the table...
That's yaw.
That's yaw.
That's like what your car does when it rotates, it turns.
Yeah, and then if you do a wheelie on your bike or lift your fingers off the table, that's your pitch. Or if you lift the palm off the table, that's your pitch. And then roll is if you start rolling your hand along the table with your, around your arm.
Yeah, so on a plane, the rudder controls the yaw, the elevator controls the pitch, and the elevon, or the other one.
Well, I don't fly a plane. Although I'm gonna try and get a flying lesson this year.
Yeah, well, we'll have to know that.
Yeah. So we will have to know that. Yeah. So so you've got those 3 axes of rotation. Now you can have something that is measuring if you're out in space, in particular, if you're out in space, obviously it's really hard to tell what the hell's going on because you've got very little sort of frames of reference or landmarks to judge where you're pointing.
You don't know where down is.
Yeah, where you're pointing up or down or yawing or rolling.
Well, yaw and roll you can know because just because it's relative to your spacecraft, but it's just a problem of like the up and down of the entire universe as opposed to your spacecraft.
Yeah. So, but what you want is like a system, and most famous, you've got that 8-ball thing that's in the cockpit of a spacecraft, and that kind of tells you roughly where you're pointing.
I mean, they put those in planes, and you'll see it on like a 747 or something.
So they're known as inertial measuring units, I think. So they're actually measuring your inertial. Where you are in inertial space, and they also
they're called nav balls.
Your nav balls, yeah. I think the nav balls will just show your yaw and everything that you're kind of positioning, whereas the inertial stuff actually shows your acceleration and things like that as well, because they've got motors that are looking at the gimbals. So the gimbals are 3 rings that surround the actual platform itself that's doing the measurement.
Yeah, and they start off 90 degrees from each other, so that you could theoretically get any rotation of that gimbal relative to the spacecraft with those 3 axes.
Yeah, but what's the problem with that?
Well, the problem is, let's say we have these three rings, and they're each rotating on axes 90 degrees from one another. If you rotate one of the rings 90 degrees, then you have two rings that rotate on the same axis, which means that one of your rotations, one of your degrees of freedom has now disappeared. You can rotate on one axis twice, another axis once, and the final axis you can't rotate on.
Which renders your inertial measurement unit useless, right?
Well, it just messes it up completely on one axis, or at least one axis.
So you lose one of your axes, so you're no longer measuring you're no longer doing any kind of dead reckoning along that.
You'll only
one
be
axis,
measuring pitch and yaw, or roll and yaw. You won't be measuring like all three.
So what's the solution? What was the Apollo solution to that?
They didn't have one.
They did.
They sort of had. They had a kind of cheat.
The early discussion was that they would have a fourth gimbal, so you can have a fourth ring that you can arbitrarily move, to stop that from happening.
Yeah, but the problem with that, like again, you'd have to
complexity.
You'd have to motorize that. Yeah. It wouldn't have to be free like all the others are passive. But their solution with the three thing was to just have a light on the dashboard of the Apollo module. That there was just a gimbal lock, and then it would light up if you're close to two rings aligning. Yeah. And so if they were maneuvering their spacecraft and they saw that light up, they would have to move just in a random, or just to avoid gimbal lock.
Yeah, and when it gets close. When it gets close to gimbal lock, like 70 degrees, I think the light comes on. And when it gets to 85 degrees, the system just shuts up. So it never actually gets to gimbal lock. So what Michael Collins was doing when he was in the lunar module was that he was trying to look for Buzz Aldrin and Neil Armstrong by manoeuvring his craft, and trying to look out the window. Because, of course, the window, you can't sort of look round the corner. So he's manoeuvring his craft. But he realised he can't get it too close to gimbal lock, so it's like frustratingly you've got to keep an eye on what you're doing, and every time he's just about to see them, he gets close to gimbal lock and has to come back off.
And this is a massive problem also in computer graphics as well. So anytime I'm doing like animation and stuff, I'll often find that I can't rotate an object in a certain direction because because of gimbal lock. But the solution is obviously. Or maybe not obviously for most people, but
it definitely isn't obvious.
But
before you get there, the bit that I found interesting was that the reference point that you're using, where your yaw, roll, and pitch are all at 0, is your landing spot on the moon. So if you have your landing spot on the moon as 0, 0, 0, that's where it's set. Yeah. So that as you're landing, you're trying to get all of them to 0.
You want to point up. You want to have it all at
yeah. And so if you're going down, so this is an interesting one. If you're going down and you pitch up, is it plus 30 degrees or minus 330? So is it that way or that way? And here's a really good one. So if you get your right, it's a right-handed system. So if you point your thumb forwards, right?
Yeah.
Your roll is in the direction that your fingers are pointing. So that's right. So that's positive. Yeah. So most of them are right-handed systems. So the roll is in that direction.
I suppose that kind of makes sense because our clock goes the positive direction.
Yeah,
clockwise.
It's clockwise. So
that it kind of makes sense.
In a right-handed system. Yeah, in the direction of travel. But that's cool, isn't it? So you can have a look at those. You can have a look at that. So there is to avoid gimbal lock. There's a couple of solutions. There's that fourth gimbal, which they had on Gemini. So Armstrong thought that Michael Collins had been very, very funny when he said, "Can I have a gimbal for Christmas?" Because they'd both been used to 4 gimbal systems on Gemini, but they decided not to have it for Apollo because it's too expensive. It makes it more complex. And Paul Fjeld, who's a friend of the podcast, he's written in quite a few times. His kind of conclusion from that was that that obviously Apollo was less about innovation and more about time management. It was more about innovating management and working to Kennedy's, we've got to do this before the end of the decade. So it's like, we've got to get this stuff off the shelf. So things like the Polaris missile system had 3 gimbal IMUs, And so they went with that instead of designing and making something heavy that was better.
Yeah.
So they just went with kind of what's the expedient thing to do. So, you can tell from these kind of decisions, it's much more about time management than it is about technical innovation in some ways.
If you can go to the moon with only three axes, it's
But here's the other thing: because you've only got these 3 axes and you want to avoid gimbal lock, they had to map out the entire orientation of the spacecraft against stars for the entire journey to the moon to make sure that there wasn't a point where you were going to go into gimbal lock. So there's like various things that they had to do to avoid this gimbal lock situation. How cool is that?
That is quite cool, yeah.
So what's the other solution other than the 4th gimbal? Go.
Well, it's kind of a 4th degree of axis. So you have X, Y, and Z, but then you add the W, right? So that's the 4th axis. But you're using a number system called Quaternions.
Okay.
And so if you're familiar with complex numbers, which are essentially you have a number which is made up of real numbers, so that would be any number that you can count to, like 1, 2, 3, 4, etc. But then it also has a component of how many multiples of the square root of -1 it has.
And that's useful, isn't it, for graphing in more than 2 dimensions?
Well, 2 dimensions.
Oh, 2 dimensions, yeah.
Yeah, so for example, the Mandelbrot set is mapped on a graph which maps how many square root of -1s a value has and how many real numbers a value has.
Yeah, and imaginary numbers definitely are really useful for plotting things like sine waves and.
Well, yeah, and they also they turn up in quantum mechanics and
well, anything that has a wave function, they're blooming useful, right?
Yeah, just any kind of 2D stuff. But the problem with that is obviously you can't use 2 axes to represent 3D rotation. You actually need 4 axes to avoid gimbal lock. And that's where, that's what quaternions are for. So quaternions are an extension or a generalization of complex numbers, where instead of just real numbers and I, you have real numbers I, J, and K. And all of...
So that imaginary, geomanagary,
and imaginary
numbers.
Yeah, all of the,
Yeah.
And then just real.
I nicked George's joke from earlier.
Yeah, it's like... But anyway, so you have these, and then with that you can use that as the method of like transcribing a rotation. So any rotation will be some combination of these values for how many I's you have, how many J's you have, how many K's you have, and how many real numbers.
Yeah, so instead of having these gimbals, you can just have a piece of equipment that's measuring the movement that's directly attached to the hull of the spacecraft, presumably, and then just needs to know where it is, and then each so you've got 4 units measuring where its movement, and then you can apply that in a quaternion to get your exact orientation of your spacecraft.
The problem with quaternions is that they're not intuitive at all. Like you can't look at unlike with Euler rotation, you can look at 90, 90, 30 and instantly like kind of imagine what that would look like. You just have to think of those rotations in your head. But with quaternions, you can't. There's no intuition whatsoever, really. Like unless you really study it and know it, which I haven't. It's impossible to think of, intuitively, which is a problem. But for computers, computers just do calculations anyway, right? So there's no problem for computers to understand quaternions. But the problem is with humans. So maybe it's converted into Euler for the humans after the fact.
Yeah, well, I was reading, because I was trying to get my head around this, and I think things like your quadcopters. You've got your little chips on board that are measuring your quaternions. So they've got these little inertial sensors that are part of a strap-down system. Apparently, that's what they're called, and then that gives you your sense of rotation and acceleration as quaternions, and then that can be transposed into Euler angles for use on the motors themselves. So the motors then adjust your quadcopter accordingly.
So you get the best of both worlds.
Get the best of both worlds,
It's intuitive, but it's also you completely avoid gimbal lock.
Yeah. Of course, you can avoid gimbals as well by having fluid bearings or flotation chambers with it all in.
Now you kind of have infinite degrees of rotation at that point, which is what a nav ball is. It's like a ball inside of oil.
Yeah.
That has within it
Yeah, so how did Lord Kelvin didn't exactly like these, did he?
Well, I mean, I don't think anyone does.
So this is how Lord Kelvin described it. He said, Quaternions came from Hamilton after its really good work had been done, and though beautiful and ingenious, have been an unmixed evil to those who have touched them in any way.
It's true. I didn't know Lord Kelvin was Irish.
Yeah, he's from Belfast. He's from Belfast. As is Hamilton. Is Irish. He's from Dublin, I think. Hamilton was invented the Quaternion.
Wow.
Yeah. The Hamiltonian appears in quantum physics quite a lot as well. He's quite a clever chap.
Although Hamilton never knew anything about quantum mechanics.
No, he wouldn't have done.
Despite being...
Yeah, it's more to do with the fact that he's very good. He's the Hamiltonian's part of calculus, isn't it?
Yeah.
Yeah. Anyway, he came up with Quaternions, and Kelvin was very annoyed by them because they're totally counterintuitive, but very, very useful, like you said, for animators and stuff like that.
Yeah.
There's a really good clip, isn't there, of a football game where someone's heading the ball, and because of the way that it's animated and gimbal lock, it looks like their head has kind of flipped over in a kind of disgusting way.
That recently, with the International Space Station doing a crazy spin after a Russian...
Yeah, the Norca module.
Just randomly firing. Loads of people tried to animate it in Blender, but forgot... But because all of the data for that rotation was in Quaternions, you had animations of the space station randomly flipping around because they forgot to convert to Quaternions before. But often I actually just switch to Euler in Blender and things, like when I'm doing computer graphics, just because it's just easier. And as long as you avoid gimbal lock,
Yeah.
If you can go to the moon, you can make an animation.
That's a really good point. That's it, George. Going to keep this nice and sweet. We're going to keep this a nice and sweet short podcast. Actually, I will have to say, my favourite thing happened this week.
What?
William Shatner went to space.
Really?
Yeah, the person who played Captain Kirk in his 90s becomes the oldest person ever to go to space, possibly the most famous person associated with space as well.
Yeah, that is true. If only Mark Hamill went to space.
Yeah, actually, Mark Hamill should go to space. Maybe someone from the Star Wars universe is going up on the next Jeff Bezos flight because they're unnamed at the moment. That's a really good shout.
Yeah,
Harrison Ford.
They should get the entire cast of
God.
Imagine that, George Lucas,
Mark Hamill, and Harrison Ford. Unfortunately, Princess Leia can't go up.
Oh yeah, I was gonna say, but then I just realised.
Yeah, no, that's a bit unfortunate. So
Chewbacca,
Chewbacca, R2D2, and C-3PO.
Yeah.
No, but it'd be quite good if Harrison Ford and Mark Hamill are on the next flight. That would be so cool.
That would be really.
And
cool.
then Harrison Ford could turn around to Mark Hamill just as about to take off and say, "I've got a bad feeling about this." Oh yes! Oh my god! That's really cool.
That is really cool.
Actually, that's a really good bet that one of those two might be on the next Blue Origin New Shepard flight, which is happening this year. They're going to try and make them 12 times a year.
12 times a year. That's
and Virgin Galactic are having a nightmare. They've been massively delayed until for at least 6 or 7 months. Because they're testing how strong the materials are, because obviously there's some strain on some component that's more than they thought it was, and so now they've got to test if the materials of that component are strong enough to take it.
They should just use the same material that Nokias are made of.
Yeah.
Because that is basically the best material, surely
in the world.
Yeah, it's definitely the strongest.
Yeah, try and destroy a 3310.
Impossible.
Impossible. George, what are you doing this week?
I'd probably be... I'm doing lots of fractal stuff. Using Quaternions, weirdly, but also just complex numbers generally.
Nice.
But as well as working on my short film as well.
Cool.
And school.
And school. Yeah, school gets in the way, doesn't it? Yeah, I've got to do school as well.
So we're both just doing school.
Yeah, we're just both doing school. And then we got half term. Yes,
Yeah.
get in. Right, okay. I think that's about time we leave the Spodcats with their heads blown on Quaternions and Gimbal Lock. Bye-bye, Spodcats!